Okay, we just did this question here, but a lot of people look at this thing with two lines of sight going down from a building, and they can't see the three-dimensional sort of wedge of cheese that there is sitting here, and it's a lot easier for them to do it a different way, and we can change this 3D picture into a 2D picture by doing something Mr. Autry calls a development. And we're going to look at that in the next slide. You see this piece that's BCD, this part here? Well, what we're going to do is we take this BCD and we place it right on the bottom. So you can see there's that one triangle, the orange one there that's right on the ground. Now we're going to make this problem easier to look at, hopefully. Well, there, it's easy to see ABD. There's a right-angled triangle coming straight up here. But we're going to pull this triangle down and see the right-angled triangle right there. We're going to pull the 12 right down there. There's 12. There's 45 degrees, the 45 degrees. We pulled this triangle and we put it right on the ground here. And we pull this triangle ACD down, but there's no information there. There's nothing, so we don't really need to do that. It's just these three triangles. And let's just see how Mr. Autry does it from here. Now that he's got this, first he looks and he goes, gee, if I knew those two sides, I could use the law of cosines, BD squared plus BC squared minus 2BD times BC times the cosine of 55. So my problem is looking at this right-angled triangle and going, oh, 45 degrees. That's opposite over adjacent. And Mr. Autry does it this way. He takes BD and he takes BD. He's doing this triangle here first, over here. He takes this BD and he puts it over 12. PD over 12, but for 40 degrees because it's the opposite. This would be opposite over adjacent. But if we turn it upside down, we'd like the BD on top. He turns tangent upside down, makes it 1 over tan 40 degrees, and he gets exactly the same answer we did in the first other way. It's just his way of doing it. And he goes the same thing for BC. BC, that's really adjacent over opposite, but if we go 1 over tangent 45 degrees, the reciprocal, it makes it opposite over adjacent. So that's the way he likes to do it. Then he takes the 12 and multiplies it up, 12 over tangent 45 degrees. Well, here's our two ways of doing it. We just substitute those two things. And if you wanted a super accurate, even more accurate than rounding, you're not doing any rounding. If you wanted the most accurate answer you could, you'd put the exact values in here. And you just put it into your calculator. There's BD squared, BC squared minus 2 BD BC times the cos of 55. He got this and then square rooted it and get 12.31, exactly the same answer. And there you go.